Hi guys and girls on YouTube, and welcome to my channel. Before I start this video, I must point out that there might be the odd duplication or error, or something might not be in the correct order in the video. And the reason for this is a project I've been building in the loft at home, and I don't have a lot of spare time. So I actually started this about 10 months ago, and it's been filmed in the camera in several parts over the last 10 months. So things might not be in the correct order, but you'll get the general idea. So in this video, we're going to be taking a trip back to 1976, when I was just a 12-year-old boy, the winter of 1976. And I was wandering down the main street, and I went into W.H. Smith to look at the electronics books. And I actually found a magazine on the shelf. It was the most amazing magazine I'd ever seen as a 12-year-old boy. And over the years, I've made lots and lots of projects out of this magazine. So let's just take a look what it is. Right, so this is the magazine in question. It's called Etty Circuits #1, and it actually cost £1.50. And there it is, look, the winter of 1976. Now, I've made enormous amounts of projects out of here. If we take a quick look, it's absolutely packed with different circuits that you can build. Now, what I didn't realise at the time is all of these are actually just reprinted from a magazine called Electronics Today International, which I went on to take as well. I've got most of these as well. So if we take a look here, you can see where I've built things. I've actually I've drawn that on there because I've etched circuit boards. And interestingly enough, there's one here for a 20-watt amplifier. Now I've actually been through my archives and I've actually found that, which I built in 1982. Right, so we take a quick look at this, but we don't want to go too off track. Because this is not what this video is all about. So that was built from the Etty Circuits #1 magazine, 20-watt amplifier. So I was looking through the loft one day through my electronics magazines, and yes, I have got thousands of them. I've got every one I ever bought, and I've never thrown any single one away. And I came across this. It's a Practical Electronics magazine, June 1977. And the first thing that struck me is this telly in the picture. I've got a telly almost similar to that. It's a Thorn 1400, but that's a single standard. The one I've got is a dual standard, but it's more or less the same telly, dating from about 1967. And I thought, wouldn't it be good if I was to build this, and if I could reproduce this picture, if I built that and displayed it on there, and had a picture of me and my wife to replicate this picture on the front on the kitchen table. I thought that'd be a good idea for making a YouTube video. So that's exactly what I've done. So let's take a really quick look, because I forgot now how much of this is in the video. But that's what we're going to do. We're going to make that and we're going to display it on that telly. Right, so that's the PCB made up. All we've got to do now is just drill it. Right, so that's where we're up to so far. I've got half the parts on, just the other half to go now. Obviously when I've done, I'll clean all the flux off the board and spray it with a conformal coating like a varnish. But yeah, it's coming on. Right, so here's the progress so far. I've wound the oscillator coil. What I'm going to do is I'm going to set this up in stages before I put the chip in, because it's a MOS chip, and very early MOS chips weren't that well protected against static electricity. So I'm going to play with the RF modulator later, but we're going to set up the oscillator now, and put the chip in when everything's ready. So according to this here, the oscillator frequency should run at 2.097 megs. So let's just set up that first. So for this I've got a frequency counter. That's the easiest way of doing it. Right, so we take a look at that. That's not so bad. 2.097. So that's the clock oscillator setup. Next thing I'm going to do is play about with this RF modulator. Right, so onto the RF modulator next. Now it says the output from this modulator is fixed at about channel 50, but that might not be too desirable, and you might want to adjust the output from the modulator. So what I've done, if we take a look here, it's capacitor C8 that tunes this strip line. I've actually replaced that. It's 33 PF. I've actually changed that to 27 PF, and in parallel with that capacitor I've put a 1 to 5 PF trimmer. Now that will vary the frequency of the strip line and also alter the RF output. But one of the problems I've run into, this transistor 2N3663, I haven't got one of them. So I've been looking into substitutes. Now I found it'll work with a BF180, and I've got about 100 of these in stock, so that's a good choice. But I found with a BF180 it won't oscillate at a very high frequency, so I've had to make another substitute for that transistor. I've actually changed it to a 2SC2570, and with this modification here, I think the analog TV band 21 to 69, it's about 470 megs to 890. Now I couldn't get the BF180 oscillating right at this top end, but with the changes I've made, the 2SC2570, and reducing that and adding a trimmer, I can get this now. I can get a variable RF output between channel 33 there and 69. So now we can vary the output from the modulator between channel 33 and channel 69. And if we move over to the board there, you can see the replacement transistor I've got in, and also a little Philips 1 to 5 PF trimmer. So I've had that up and running. That's absolutely perfect. I've fitted the IC in the socket. Now I have actually had this board running, and I've had a picture on the screen, but I found regardless of what it says in the instructions, you do have to tweak that coil a little bit off frequency to get the picture to lock. So the next stage now is to get some sort of instrument case and get this all boxed up, and then we'll give a demonstration of it actually working. I've just put that wire link on temporarily while I get a rotary switch so we can select the different patterns. But yeah, it's coming on really good. So I'll stop the video now, and we'll come back when we've got an instrument case and it's all boxed up. Right, so I'm actually in the loft at home now. I'll just give you a quick scan round. There's not actually a great deal of room to move because I've got that much stuff in here. But also needs a bit of a tidy up here on this bench. As you can see, I don't work as tidy here as I do at work. But anyway, on to the project. So the new old stock instrument case has arrived, RS Components, and all credit to my friend Nigel Goodwin, who's actually made he's designed some front panels for this project. So I've actually cut one. I'll just give you a quick look at what it's going to look like. So that's the case, and that's the panel, and the panel's going to go into there like that, and we're just going to drill it out now. Here's the that's the board all made up. I've actually had this partially up and running. That's the back view of it. It just wants spraying with a conformal coating now to protect the bare copper. That's the rotary switch all plumbed in, ready. So that's the PCB into the case. As you can see, it fits absolutely perfectly, and we've just got space down here to build the mains power supply next. In fact, what I think I'm going to do before I carry on is I'm going to tidy up a bit here, because as you can see, I've got lots of different projects going all at the same time here. So I'm going to tidy all this lot up, and then we'll just dedicate the space just to finishing this project. Right, so that's very slightly better. Now at least we have a little bit of working space here to carry on with the project. Right, so with most of the build completed now, we're actually running out of space in this case. It's a lot tighter for space than what I thought, so what we're going to have to do is build a vertical power supply. Right, so that's the transformer. I've cut a piece of copper clad. I've not filed it down yet, but we're just going to have to draw the pattern on there and etch it off first, but I'll show you where it's going to go. And hopefully that should just slide down them runners, and that's it. A vertical power supply in the case. Right, so that's the print for the power supply. I've just got to draw them with these pens now onto this copper clad, and then we'll etch it off and drill it. Right, that's the board drawn up. Let's get etching. Right, now that's the power supply all built up and tested. I've actually brought this to work with me, so I can just finish it off, and I'll show you the reason for that in a minute. Now as you can see, it's a bit of an unusual shape because it's designed to fit in a tight space. That's the back view of it there. Now I've deviated from the power supply in the magazine, just a very simple one, but this is actually a regulated power supply, and I know what you're thinking. I've overcomplicated it by building this circuit when I could have just used a 709 regulator. Well, the thing is, I don't think 709 regulators, the 3-terminal regulators, were built in the 70s, well, not 1976 anyway. And I think this handmade one is more in keeping with the original design. So let me show you where I've got this design from. Well, if you remember me telling you about the ETI Circuits #1, which I bought in the winter of 1976 as a small boy, I've decided to build it from here because this is more in keeping. It's the same year, and if we turn over, if you can see in the magazine there, I've actually labelled a lot of these, and the reason is because I made quite a few of these power supplies many years ago, and it's been very good, and I thought that was more in keeping than just using a 3-terminal regulator. So that is a couple of the reasons why I've actually overcomplicated the power supply. Now the real reason I brought this to work with me is not just so I can test it. I want to spray the back of the board with a PCB lacquer, and I don't really want to be doing that at home in the loft in a confined space. So I brought it to work here where I have plenty of aeration and plenty of space. So here we go, a quick coating of PCB lacquer on the back of the board. Now you don't want to be breathing this in, it is very toxic, and that's the reason I'm doing it here. Right, and that's it, all finished. I've labelled it up, 9 volts out, and let's just take a look at the back. See how nice and shiny that is, and also protected against airborne corrosion, the bare copper. Right, so all we've got to do now is take this home tonight when I go home, and we'll just carry on with the build in the loft. Right, so as we approach the end of this project, I've just brought it to work with me again because we've got a little bit better light here. So let's just take one final look, because this is all ready for the final assembly. That's the front panel all drilled, the switches on. That's where the speaker's going to go. I've not just glued that in yet, but all the cases drilled out. You've got 3 holes on the front for the 2 for the paddles and 1 for a manual serve button. That's the board in its final resting place. On the back we've got the RF outlet. We've got the figure 8 for the mains input, and yeah, so that's the we're approaching the final build now. All these wires just want connecting up, and then I'll show you one last picture of it when it's all connected, and then we're up and running, cooking on gas, as they say. Right, so there it is, all assembled. Now I've had to actually bring this to work with me because I found a couple of little problems, and I don't have an oscilloscope in the loft, so I've had to bring it to work to do it. The first one was there was quite a lot of there was a hum bar in the picture, unacceptable. So what I've cured that, I've replaced the reservoir capacitor here in the power supply with a bigger one. And while I was scoping the power supply rail, I also noticed there was some unacceptable RF ripple on the power supply, probably coming from the modulator. So how I've cured that, I've decoupled the input to the power supply there with this 100 nanofarad disceramic capacitor. And the third little problem was, when the speaker beeps, it actually caused a disturbance on the picture. Because the RF modulator in the original design is undecoupled. So what I've done is I've decoupled the RF modulator here with a capacitor, and that now gives us a super quiet supply to the modulator, so we don't get, or we shouldn't get, any interference now in the picture when the speaker beeps. Yeah, I just got to cut that off, and then I can get a knob on there. Well, that's the back RF socket figure 8. 3.5mm sockets there for the paddles, and that is for a manual serve button rather than an automatic serve. Right, so to make the paddles, I've just used a couple of these cheap instrument cases, 100k part, and just a bit of screen lead. So there we go, 2 paddles now. Tell me when you're ready.
Ready?
Okay, go then. Oh, tell you got a dry joint.
Go.
Okay guys and girls, many thanks for watching my video, and I'll catch you in the next one. Have a good Christmas. Goodbye.